Good morning, students. Today we will discuss about how to find the limits and integration to the given region. Now we will start with example. Evaluate double integral over r y dx dy, where r is the region bounded by the parabolas y square is equal to 4x and x square is equal to 4y. First we have to draw the given region. So this is x-axis, this is y-axis, and y square is equal to 4x is a parabola symmetrical about x-axis. Y square is equal to 4x. Next, x square is equal to 4y is also a parabola but symmetrical about y-axis. X square is equal to 4y. Now going to the solution, the given parabolas are y square is equal to 4x and x square is equal to 4y. We have to solve these two equations. We get the intersecting points of two parabolas. How to solve it? Then you can substitute y is equal to x square by 4 in the equation y square is equal to 4x. We are getting x square by 4 whole square is equal to 4x. And that is x power 4 is equal to 64x. So 1x is cancelled. We are getting x cube equal to 64. Or simply we can solve x power 4 minus 64 x equal to 0. X common, x cube minus 64 is equal to 0. So one value x is equal to 0, one value x cube is equal to 64, x is equal to 4. So we are getting the values for x are 0 and 4. By using these two values we find the y values. So if you substitute x is equal to 0, y is equal to 0. If you substitute x is equal to 4, 4 square by 4, y value is also 4. So the two parabolas intersect at the points 0, 0 and 4, 4. 0, 0 and point intersecting point P of 4, 4. The shaded area between two curves is the region of intersection. This is shaded area between two curves. So, x limits are x is equal to 0 to x is equal to 4. If you want to find the limits to the given region, you have to fix one limits. So, that are I am taking x limits are fixed limits. So, x is equal to 0 to x is equal to 4. So, that's why x limits are x is equal to 0 to x is equal to 4. And going to the y limits, y must be function in x. So that's why we are taking the y limits in terms of x. So y limits means it's a vertical limits. Vertically you can identify the region. In the vertical direction, the limits are started on the curve x square is equal to 4y. X square is equal to 4y. So that's why what is the y value on this curve? Y is equal to x square by 4. And the region and on the curve y square is equal to 4x. So what is the y value on this curve? Y is equal to root 4x. That's why we can write y is equal to 2 root x. So x limits are 0 to 4 and y limits are y is equal to x square by 4 and y is equal to 2 root x. So now double integral over r y dx dy, write as x is equal to 0 to 4, y is equal to x square by 4 to 2 root x, y dx dy. But we should integrate with respect to y first because of y limits are x square by 4 to 2 root x. So y integration is y square by 2. Substitute the limits and here 1 by 2 is constant right outside. Y square you can substitute upper limit is 2 root x, it becomes to 4x, and the lower limit is x square by 4, y square means here x square by 4 whole power 4 whole square, we get x power 4 by 16 into dx. Now you can integrate with respect to x. 1 by 2 into 4 into x integration is x square by 2 minus 1 by 16 into x power 4 integration is x power 5 by 5. 16 into 5 is 80. Limits are 0 to 4. Limits are 0 to 4. Now you can substitute the limits 1 by 4 into here 4 is cancelled by 2, that is 2 into x square. 2 into 4 square value is 32 minus 4 power 5 is 1024 by 80. So then you can simplify. We are getting the solution is 48 by 5. Next example is Evaluate double integral over R xy dx dy, where R is the region bounded by x-axis ordinates x is equal to 2a, bounded by x-axis ordinates x is equal to 2a, and the curve x square is equal to 4ay. So here one is a parabola, ordinate is a straight line. X square is equal to 4ay is a parabola symmetrical about y-axis, and x is equal to 2a is a ordinate parallel to the y-axis. So the given parabola is x square is equal to 4ay, x square is equal to 4ay, and x is equal to 2a is a ordinate. Now the double integral over R xy dx dy is the same as double integral over R xy dy dx. Let us consider the fixed x. So why we fix the x? So here x limits are constant limits, so that's why we can fix x is equal to 0 to 2a, and y limits are in the direction of y. The region is start on x-axis. On x-axis y is always 0, so that's why y is equal to 0 to y is equal to, what is the parabolic equation? Y x square is equal to 4ay, right? For y is equal to x square by 4a. So for a fixed x, y varies from 0 to x square by 4a. Here we are fixing x limits. X is equal to 0 to 2a, y is equal to 0 to y is equal to x square by 4a. In this direction we take the y limits in terms of x. This is the shaded region. Now we have to write the integration as integral x is equal to 0 to 2a, y is equal to 0 to x square by 4a xy dy dx. First we integrate with respect to y. Y integration is y square by 2, 1 by 2, right outside. Y square upper limit is x square by 4a whole square, so x power 4 by 16a square multiply with 1 by 2, we are get 1 by 32a square is a constant. Next x power 4, here one x is there, x power 4 into x power 5. X power 5 integration is x power 6 by 6. Limits are 0 to 2a. If you substitute the limits, we are getting the solution is a power 4 by 3. Next example is find double integral x plus y whole square dx dy over the area bounded by the ellipse x square by a square plus y square by b square is equal to 1. So all of you know the limits for the ellipse are minus x is equal to minus a to x is equal to a, and in the direction of y, constant limits are y is equal to b to y is equal to minus b to y is equal to b. But we need to take one is a fixed limits and other one is from curve equation. Why we should write y in terms of x, y is equal to f of x form. So that's why we are taking the equation of the ellipse x square by a square plus y square by b square is equal to 1. So y square is equal to y square by b square is equal to 1 minus x square by a square. So that's why y square is equal to b square by a square into a square minus x square. Here we are taking the LCM. We get a square minus x square, b square by a square, right outside we are getting a square minus x square. And y is equal to plus or minus, apply the root on both sides, we are getting y is equal to plus or minus b by a under root of a square minus x square, or a square minus x square whole to the power of 1 by 2. The region of integration is x limits are minus a to plus a, because of we are finding the integration for whole ellipse. So that's why we are taking total limits minus a to plus a, and the next one is minus b by a under root of a square minus x square less than or equal to y less than or equal to b by a square minus x square whole power 1 by 2. So now we can write the integration with the limits x plus y whole square dx dy. We can expand a plus b whole square form x square plus y square plus 2xy into dx dy, and separating as a two parts. X square plus y square is a one part, 2xy as a one part. After that, here x square plus y square. Here x power is 2, y power is 2. So if you integrate first with respect to y, you can integrate for even function. So after that, if you go through with x square, that is also even function. But here going to the function 2xy, if you integrate first with respect to y, 2x consider as constant, we can integrate y. Y is a odd function. So that's why this integration becomes to 0. We know that integral minus a to plus a f of x dx is equal to 0 if f of x is odd. So by using that rule, the second term integration becomes to 0. So that's why we can find the integration for only x square plus y square dy dx. So first integrate with respect to y. X square is constant. Integral dy is y plus y square integration is y cube by 3. And we have a possibility integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f of x is even. So by applying that rule, I am writing y limits are 0 to b by a under root of a square minus x square multiply with 2. So that's why we are getting 2 integral x is equal to minus a to plus a xy square plus y cube by 3. Limits are 0 to b by a under root of a square minus x square into dx. Substitute the limits. We are getting the value is b by a x square under root of a square minus x square plus b cube by 3 a cube a square minus x square whole power 3 by 2 into dx. Now here root of a square minus x square into x, it's integration is difficult to find it, so that's why we can change into polar form, that is x is equal to r cos theta. Here r value is a, x is equal to r cos theta, dx is equal to derivative of a sin theta a cos theta d theta. So now going to the limits, when x is equal to 0, then sin 0 is 0, theta value here x is equal to 0, sin theta equal to also 0, theta is 0, then sin value is also 0. X is equal to a, then theta is equal to pi by 2. X is equal to a, you have to substitute it. Sin theta is equal to 1. Sin is 1 at pi by 2, so that's why theta is equal to pi by 2. Then you can change into pi by 2. Then write the values a cube b sin square theta cos square theta plus substitute all the values, x value, y value, dx value. So after substituting that, we are getting a cube b sin square theta cos square theta plus a b cube by 3 cos power 4 theta d theta. So now you can separate the integrations and apply the formulas. I wrote the formulas here. Integral 0 to pi by 2 sin power mx cos power nx dx. When n is an even number, we can multiply with the pi by 2. M and n both are even, you can multiply with pi by 2. Then here also one function, integral 0 to pi by 2 sin power nx dx, integral 0 to pi by 2 sin power nx dx value is n minus 1, n minus 3, n minus 5, so on by n into n minus 2, n minus 4, so on into pi by 2 if n is even. Otherwise, add, you can multiply with 1. Here, sin square, cos square, both are even. So, that's why we are applying the formula. M is 2. 2 minus 1, 1 by m plus n, 4 into m plus n minus 2. That is 1 by 2 into both are even, pi by 2. Next one is cos power 4 even, so that's why I am applying this formula. 4 minus 1, 3 by 4, and next 4 minus 3, 1 by 4 minus 2, 2 into pi by 2. Then simplifying that, we are getting pi ab by 4 into a square b plus b square. Here we are taking the common ab by ab pi by 4. So here a square is remaining part plus here b square. So pi ab by 4 into a square plus b square. Cancel this b. It's a mistake. A square plus b square. So now these are the practice sums. Should practice it. I will check the practice notes. Next topic is double integrals in polar coordinates. To evaluate integral theta 1 to theta 2, r1 to r2, f of r comma theta dr d theta over the region bounded by the lines theta equal to theta 1 comma theta equal to theta 2 and the curves r is equal to r1, r equal to r2. We first integrate with respect to r between the limits r equal to r1 and r equal to r2, keeping theta fixed. Here theta is fixed because of theta is an angle, always it is constant, so theta is fixed. We can take the r limits in terms of theta. The resulting expansion is integrated with respect to theta from theta 1 to theta 2. In this case, r1, r2 are the functions of theta and theta 1, theta 2 are the constants. First, how to evaluate the integral in the polar form. Directly they are giving the limits 0 to pi, 0 to a sin theta r dr d theta. So 0 to pi are theta limits and 0 to a sin theta is the r limit. Because of already we discussed r is a function in theta, so that's why 0 to a sin theta is r limits and 0 to pi is theta limits. So r integration is r square by 2, 1 by 2 is constant. You can substitute the limits. We are getting a square sin square theta. A square by 2 is right outside. Sin square theta, it is not possible to write direct integration, so that's why we are applying the formula sin square theta is equal to 1 minus cos 2 theta by 2 into d theta. Now here 1 by 2 is constant right outside. A square by 4 into integral d theta is theta minus cos theta. Integration is sin 2 theta by 2. Now substitute the limits. Upper limit is pi minus sin 2 pi by 2 and lower limit is 0. So sin 2 pi value is also 0. That's why solution is a square pi by 4. Next example is evaluate integral 0 to pi integral 0 to a into 1 plus cos theta r square cos theta dr d theta. Here first integration is function in terms of theta. So that's why these are the limits for r. The remaining limits for pi. So integral 0 to pi cos theta. Why first you have to integrate with respect to r. So cos theta right outside. So r square integration is r cube by 3. Limits are 0 to a into 1 plus cos theta d theta. Integral 0 to pi cos theta. You can substitute upper limit a into 1 plus cos theta. It becomes to a cube 1 plus cos theta whole cube by 3 into d theta. Lower limit is 0. So that's why we are getting 0. So next one is here a cube by 3 is constant right outside. Integral 0 to pi cos theta into 1 plus cos theta. I am substituting 1 plus cos theta is equal to 2 cos square theta by 2. We have a formula cos square theta by 2 is equal to 1 plus cos theta by 2. So 1 plus cos theta is equal to 2 cos square theta by 2. So substitute it and it is the value of 2. And here again I write cos theta is equal to 2 cos square theta minus 1 and here cos square whole cube becomes to cos power 6 theta by 2. 2 cube value is 8 right outside into d theta. I am separating as a 2 integration parts by using 2 terms. So 2 into cos square cos power 6. So 2 cos power 8 theta by 2 d theta minus 1 into so cos power 6 theta by 2 d theta. Limits are 0 to pi. Now I am changing the limits 0 to pi by 2 to here. Already 2 is there. I am changing the limits 0 to pi to pi by 2 by multiplying with 2. So that is 4 integral 0 to pi by 2 cos power 8 theta by 2 d theta minus 2 integral 0 to pi by 2 cos power 6 theta by 2 d theta. Again I am applying the formula integral 0 to pi by 2 cos power n theta d theta. If you have any doubt, you can change the theta by 2 to the 5. Means by using substitution also you can change the variable and apply the formula. But I am directly applying the formula here. Power 8 minus 1 7, next 8 minus 3 5, next 8 minus 5 3 into 1, 8 minus n minus 7, so it is a 1 by n minus 2, n minus 4 and n minus 6 into pi by 2. It is a even. So next one is power 6. It is also a even number, so that's why n minus 1 5, n minus 3, so then it is 3, n minus 5, so 1 by n 6, n minus 2 4, n minus 4 2 into pi by 2. After simplifying that, we are getting 5 pi a cube by 8. Students, we already discussed these two problems in the classroom, so that's why you can practice these two. In the next class, we will discuss about change of variable in the double integration.